All right, we're going to go ahead and get started here. Looks like we have Clarion and Fort Dodge Senior High. Who else do we have on here? What other schools? Maybe just those two? Okay, awesome. Oh, I see Danielle's on. That's cool. Southeast Valley. Good deal. Okay, we're going to go ahead and get started. So good morning. I'm Megan Cruzy, the Iowa Central Work-Based Learning Coordinator. Thank you for joining us for our Iowa Central STEM Career Discovery Day. So today you're going to be learning about STEM careers, and then our instructors will also talk about their programs. A reminder, we are going to be recording. So if you don't feel comfortable, you can absolutely turn off your camera. We are also trying it out new this time. We're streaming it live on YouTube, which is pretty cool. We had a request from some schools to do it that way. So we also have students on YouTube watching. All right. And if you have questions, which we really hope you do, after each instructor is done speaking, you can unmute yourself and you can ask, or you can type it in the chat box. And myself and the other Iowa Central staff on, we will watch the chat and ask the question for you if you're more comfortable with that. So if there's no questions, we're going to go ahead and jump in. We're going to hear from Neil Peterson first. So Neil, whenever you're ready, go ahead.
Okay, thank you, Megan. I appreciate it. So this is different for all of us, isn't it? I know the last few years I've really enjoyed coming out and visiting at the high school sites and visiting with people face to face, but of course now things have changed a lot for us. So now we've gone to the virtual environment, but we're still able to carry this on, which is really a wonderful experience. Great day ahead of you. So many good things that you're going to be able to see. What we find is there's a commonality between students when you're thinking about a STEM career. There's probably more than one career that's possible within STEM that would fit you real well. Usually the types of students that will go into STEM careers are people who like to think a lot about things. They're good visualizers. They're curious. They like to investigate. They don't mind tackling a problem. They find enjoyment in doing that. And there's a lot of careers in STEM that fit real well into that. So hopefully by the end of the day, you're going to have a good opportunity to be able to see all the different types that are available. And as always, we're always available to you as a resource. Any one of us that speak today, we're all STEM teachers. And if you have any questions, we'll certainly be glad to help you as much as we possibly can. So let's go ahead, let's dive into it. I'm going to go ahead and share my screen here. And my particular specialty out here at Iowa Central is engineering technology. We actually have two different, I guess if you want to call them strands, two different kinds of engineering strands. We have our pre-engineering strand, which David Bush is in charge of that, and he's going to talk about that a little bit at some point. I take care of the engineering technology. So we're very closely related to each other, both very broad fields when we talk about engineering. Engineering can cover a lot of different things. It can cover civil, mechanical, acoustical, structural, there's chemical, and a few others. Any place that you find those types of engineering fields, there will probably be some kind of engineering technology that's going to be associated with it. And there are two different layers of really the same type of thing. So my job, as I see it today, is I'm going to talk a little bit about the technology part of it that would support David and his people, who are going to be the conceptualizers and the managers of the process. So flipping over here first, the big question I always get from students and I get from parents when they come to visit and they're thinking about careers in engineering, and it's very common for them to talk to David. It's very common for them to come over and talk to me. They're trying to decide what exactly they want to do. And so basically I boil down engineering technology to this. If you're thinking about trying to figure out which one is more suited towards you, I can say, well, I know this much. I know that in that first definition I've got there, it's where the various forms of technology, all the different types of technology that are out there, we bring those to bear on the challenges that we encounter in engineering. And when we talk about engineering, we're talking about engineering in the broadest sense. We're talking about not only what we typically think of engineering, like a mechanical engineer, but also people like architects, people who are involved in science and physics in some way, shape, or form. They've got some kind of a problem that they're working with. They've got some kind of a concept they're trying to explain, and they're going to find it maybe a little bit challenging or difficult to do that without the right tools. The problem is that there are so many tools out there, and when you're a project manager, when you're a person who's busy with the conceptualization process, and you're busy meeting with customers, and you're busy coordinating manufacture and all the other things that are going on, you need someone you can trust to pass that process off to with the visualization and the implementation. So we're basically there because we're technology experts, and we bring that skill set to the table so that the engineer can say, okay, this is what I need. Can you please take care of it? We take that off of their plate, and we go to work with the implementation of it. That frees them up to be able to do the stuff where they have to, again, try to meet with various people in the process and coordinate all of these things. Because engineering, the design process, is a massive, massive job. There are multiple steps to it, and you have to have the right people at each step in order for it to go smoothly. Now, when people come in and they say, well, what types of technologies are you talking about? There's never a fixed list that you can give anybody. Because if you're going to be going into, say, chemical engineering as opposed to, let's say, electrical engineering, the types of technologies that are needed for those fields are different. So how in the world do you train somebody in just general engineering technology? By exposing them to a lot of different types of technologies, talking about how they work together, and then just coming to peace with the fact that when you get out into industry, you're going to be engaging sometimes technology that you've not seen before, but you have the experience with other types of technology that equip you to be able to take on those newer technologies. So it's developing a mindset is really what it's all about. It's the intersection of a lot of different things. Now, I want you to look very carefully at this and think about these 6 things that I have up here on the screen, because as you look at them, you may be able to see yourself in possibly 1, possibly 2, maybe 5, or all 6 areas. And when you think about engineering technology and you look at all the things that we do, all the things that we get our hands dirty with, at any one point, we could find ourselves working with any one of those 6. So immediately you look at that and you say, well, I can't do that. I can't, I'm not a math person. That's one I hear quite a bit. I'm not a math person, or I'm not an art person. Well, that's not really what we're saying. We're not saying a master of one thing. We're talking about jack of all trades. If you know enough about each of these, you can find ways to combine them together to compensate for maybe different weaknesses that you have by complementing the strengths that you have. So as an example, let me talk about my personal experience, because I was in engineering technology for a number of years before I got hired by Iowa Central. Back at Mason City High, I was a very average student. I think when I graduated from Mason City High, I had like a 2.81 GPA. I was your average student that liked to just have fun in high school. I knew that homework was important. I tried to get it done. I didn't always get it done, regretfully. But I knew when I look at these 6 here, there were definite things and there are definite holes that I had, that if somebody had come to me and said, well, you need these 6 in order to be in engineering technology, I would say, forget it. I can't do this. As an example, I was not a strong math student back in high school. I wasn't even a person that liked to read textbooks. I say that in front of my books. I liked technology. I liked working in the shop, doing hands-on stuff, working wood shop, metal shop, and that. I was decent at art. I did okay at that. Problem solving, I didn't have a lot of patience for it. And systems and processes, well, generally, yes. I mean, I knew how a car worked. I knew basically how different types of machines did their things, but I wouldn't have called myself very strong in any one of these areas. As it turns out, it was the perfect selection for me, engineering technology, because my interest in each of those areas was enough to carry me forward to the success level that I needed. All I needed was to have somebody take that, all of that interest and harness it and show me how it could be used. Now, what I didn't realize when I first got involved in engineering technology back in Mason City, I went to NIAC first, the North Iowa Area Community College up there. They had a program there for engineering technology. And this is where it was first formalized for me. And Mr. Brunsvold was my teacher and put this almost this exact same thing up on the board for me. He said, if you're going to be going into engineering technology, here's what the design process looks like. Now, later on, I realized through engineering classes that the design process is actually closer to 6 steps. But I thought this was a pretty good generalization here. He said, there's a concept or a challenge that comes into your company. And when it comes into the company, generally it will be the engineer right here. The engineer will be involved in the conceptualization process. They're going to meet with the people. They're going to try to figure out, okay, what exactly is the problem here? What type of solution is needed? And what are the constraints that I have to deal with? They have to identify what the goal is. And then they have to identify, what are we limited? Are we limited money-wise? Are we limited in maybe the amount of space I have to work with? Maybe energy supply, maybe thermal, maybe 100 different things. Once that engineer conceptualizes the possible solutions to it, he or she will go ahead and pass that off to us right here. And this is where we're at. We work in that realm where we take those ideas from the engineer, which may be in various stages of finished. Sometimes it's nothing more than an idea. Sometimes it's an idea that's been fleshed out, the details have been fleshed out, and it's passed to us. And what we do is we come up with the ways to visualize that concept so that others are able to see what the engineer is seeing. Because when the engineer conceptualizes, very often they will do it here, and it comes out right through here. So we might get a sketch from them, or we might get some kind of a basic computer model or whatever. From there, we take it and we make the decisions about what types of visualizations are going to be appropriate. So we may do 3D modeling, we may do 2D blueprinting. If it's something that requires simulation, we can do that too. Maybe we need to show a process that's happening and try to figure out what's the best way to explain it to people so it becomes very clear. Once we get done with that, it may be necessary for us to be involved in the implementation process. We might have to write the specifications or provide the instructions so that the people at the end of the process who do the realization, they're going to build it, they're going to assemble it, they're going to construct it, maybe they're going to put together a video on it, whatever. They have all the information they need to be able to successfully do what they need to do. So what are we saying underneath all of this? We're saying communication, communication, communication. Now there's a segment of the population out there, and some of you are part of that, just like I am, that are very good at graphical communication. That's where we feel comfortable at. There are other people who are very, very good at, say, verbal communication or written communication, and that's where their skill set's at. A person who's good at graphical communication generally is pretty successful in this type of career. The interesting thing about us is that sometimes when we go through middle school and we go through high school, we struggle a little bit because information may not be presented to us graphically. Maybe it's given to us in a book. And so when we try to read out of a book, we may learn a little bit slower than other people. But you give me a picture, you give me a video, I got it right now. That's the type of person that's usually going to be very, very successful in engineering technology. A person who has that skill set to be able to see how something works or how something functions. And because they know how important a picture is, or how important a model is, or how important graphics are, they're able to bring that to the table to communicate with other people. It's a really great skill set to have. So what I want to do with the few minutes that I have today is I want to go ahead and show you a few demonstrations about the types of things that we encounter in our work. Hopefully there'll be something there that you'll identify with. Maybe you're doing it in high school right now. You say, hey, I didn't know that was engineering technology. Let's go ahead and let's take a peek at a few of them. And I'm going to be bouncing around on the screens here a little bit because I've got a couple different browsers open and available here. So I'm going to go ahead and go to Onshape first. Now, those of you that are at high schools where they are teaching computer-aided design or computer-aided drafting, this is probably what you're familiar with. You might be working with, let's say, AutoCAD. You might be working with Inventor, possibly SolidWorks. Some of you I know are using Onshape. So how does this fit into the big picture? Well, this is a class of softwares that are very, very common in our 9-county area. Just about every manufacturer that we have within, let's say, maybe a 50-mile radius of Fort Dodge, or maybe even 80-mile radius of Fort Dodge, is using one of these softwares. So if an engineer gave me a sketch, one of my jobs would be I'd have to go in and I'd have to try to figure out how am I going to make a digital model of this. So I could go ahead and click on this front plane. It's kind of like an invisible sheet, like a drawing sheet, really. And I'm going to go ahead and turn myself towards it so I can begin to capture that idea. And there's lots of different ways to capture ideas, but we'll go with something very basic here. I'm just going to go ahead and stretch out a rectangle. I'm going to stretch another rectangle like this. Let's go ahead and let's trim these up. So I'm going to take all this stuff out. Now, what have I got here? I've got the result of the intersection of those two. I was able to take the one out, and what was left now is this L shape. This could be literally anything. It could be a doorstop, perhaps. Now, the next part of the process is I'm going to give life to this. It's not enough that's just going to be a simple sketch. It's not enough that's just going to be a simple drawing, a simple shape. But I can impart an intelligence into it so that it takes on a life of its own. I'm going to go ahead and turn on my dimensioning tool here. Let's click on this right here, and I'm going to pull this up. Let's say I want to have this 1 inch. Okay, so when I change that to 1 inch, you start to see things scale there, right? You start to see some changes happening. What we're doing is we're imparting parameters into this. Big word, but it basically means I want permission to be able to change this at any time I want. So when I go ahead and change this to 1.5, there's a scaling that happens. Now it's no longer just static geometry that's just sitting there doing nothing. It's geometry that has a measure or a degree of intelligence attached to it that allows me, the engineering tech, to be able to go back and play around with what if scenarios. And believe me, what if happens a lot when you get involved in engineering. So I'm going to go ahead and change this to 1. And then let's finish this up. I'm going to go ahead and drop this dimension down. Let's go ahead and put this to a 3 here. And there's one more thing to take care of here, but I'm not going to worry about that. That's a geometric relationship that we would dig into a little bit further on if we were actually in that course. Let's flip around and see what I got. So now I've drawn this simple 2D shape. It's flat. But now I'm going to take this flat shape and I'm going to pull it through space. And as I pull that thing through space, now it starts to take on another dimension. And as it takes on that dimension, it starts becoming something that we can consider to be solid. It has mass to it. We can treat it as though it's an actual object and we can take measurements off of it. So I could go ahead and tell it, yeah, you know what? I want to use that face there. I want to take it out 1 inch. I'm going to go ahead and say I like this. Now we created a virtual model of that part. And you know why engineers like this? People like Dave Bush, you know why they like this stuff? Because it's cheap. When I make a virtual model, we can run testing on it. We call it non-destructive testing. We don't break anything. We don't damage anything. We don't scratch anything. We can go ahead. I can work alongside David here. He could be my engineer working with me, and he could tell me, okay, that 1 inch doesn't look quite right. Maybe we could go ahead and change it to 1.5. That's an easy change for me. And then he could say, okay, go ahead and tell me what the weight of that is. Give me an idea what the surface area is on this surface. These are the kinds of things that engineers wouldn't necessarily have the time to do because of the importance of their other duties. But when people like me are involved in the process who bring the technology knowledge, it makes it much easier for David to be able to do his thing, where he simply has to come over and say, give me the answers, and then we can just head right on in that design process and keep going. This is probably the most common form of engineering technology that we see today. And this is what we would probably refer to as a mechanical type of solution. Next thing, let's go ahead and take this back off. Let's go up here. I'm going to take you into Insight Maker for a minute. So the most traditional forms of engineering technology we talked about are the CAD. When you use things like the AutoCAD, SolidWorks, Inventor, CATIA, Creo, what have you. Very, very dominant. Now we're starting to move into a new phase of engineering technology, and also in engineering where there's going to be a lot more focus on systems. Systems have always been there, and we work with systems every single day. But what we're starting to discover about systems is that systems have unique properties to them. And when we understand how a system works, it gives us, I hate to use the pun, but it gives us the insight to be able to understand what types of corrections we can make without hurting ourselves. What I did here was I made a very simple system on here using Insight Maker. It's a free software. You can go up on the internet. It runs on the cloud. Gene Bellinger was the one that conceived this. Gene Bellinger is a systems scientist. So what I did was I created this real simple system that has a bank account. I'll go ahead and click on this right here. This is called a stock. So I'm going to go ahead and pop this open. And inside of this stock right here, and a stock is you can think of a stock very loosely as a collection of items. And in my balance in my account, I said I've got 1 penny. That's all I've got. But I've committed to myself, or maybe a better way to put this is I got a rich grandpa who says, you know what, if you will go ahead and put a penny in that account, I will go ahead and double that balance every single day. Can't turn down something like that, right? But what I want to know as an engineering tech is I want to understand what's the behavior behind that, what's going to happen. And when I get to the end of that behavior, I want to see what the end result is going to be. So I'm going to go ahead and click on simulate right up here. Let's take a look at it. So it's simulating out. See what happens here? This is the magic of what they call interest, you know, when you're working with a bank account. But in this case, it's not quite interest, it's more growth. It's kind of like an exponential growth. So at day 0 here, I started off with my penny. That's all I had in the account. And I noticed as I'm moving along here, it's just doubling every day, which is kind of nice. Now I got 16 cents and 32 cents and whatever. But then something happens right in here. This is the magic of that borderline 1 that we run into in the math. And like I said, back in high school, you could have explained this to me and I never would have got it. But once we start hitting that 1, we hit that borderline of 1, something magical starts happening because things start getting big really quick. And then I start noticing that the doubling is really rocketing up. And at the end of the 30 days, I go back to my grandpa and I say, I'm ready to collect roughly about $11 million just by doubling every single day. Why do we care about anything like that? Well, it's a heck of a lot of money for sure, right? But the other reason we care about it in engineering is because in engineering, we see lots of situations where systems will behave in a certain manner. And as we're watching that change happen within that system, as engineering people, we're going to get together in the war room and we're going to discuss what we can do to improve that process, whether it's going to be an assembly line down on the floor, or whether it's going to be a machine that's leaking hydraulic fluid out in the field. We can look at this type of behavior and we can ask ourselves, what's going to happen in the future with it? At what point is it going to run out of fluid? At what point are we going to find that production has diminished so that we're not making enough money anymore? And then using that type of information, we can make really educated guesses about what are appropriate ways to get in and fix it. We're dealing with some really big system problems right now out in the world. If you think about water supply and energy supply and all that, what are our responses to that? Well, we don't really know until we understand the system and we understand how the system's behaving. So that's Insight Maker. Let's flip you over here for a second to a programming example. Now, when you look at this, I know it's going to be kind of scary, okay? Don't let it scare you. We actually worked on this problem yesterday in class, or sophomores did, and although we've talked about all of it, it's such a long program that I went ahead and gave them my copy, and then we talked about what was going on inside of here. So I'm going to go ahead and run it so you can take a look at it. Okay, so what we're working on right now in our engineering tech classes is we're working on dynamic models. We're working on how do you deal with situations where you have conditions changing all the time, and the things inside of that system act more like people than they do anything else. We call them agents. It's agent-based modeling. And so what we did was we created this world with artificial beings inside of it. They're just spots. We told the spots, when you're born, you can decide which way you want to run. You can decide how fast you want to go. You can even decide what color you are and how big you want to be. Now, we dumbed it down a little bit so it'd be easier for it to run here today. But what we did on here then, and part of this whole thing we were talking about, is when you build these dynamic models, even though technology is a wonderful thing, even technology has its limits. And when we encounter those kinds of limits in technology, what's our appropriate response to that? How do we work around those things? Now, some of the students are using Surface Go's. And so I said, let's go ahead, let's bump this up a little bit, right? And I'm talking in my office right now, so I'm using my desktop. I said, let's go ahead, let's go with maybe, instead of 15 of those little individuals, let's say 35. I just want to see what happens here. And what we did was we set up phone links. And on those phone links, we said, look, if another dot gets close enough to you, go ahead and call it and say, hey, I see you. But when it starts to get far enough away, break that phone link. So as you watch this simulation here, what you're seeing is they're moving around within that field, but every once in a while, those links disappear because the person they were talking to, the agent they were talking to, they're gone. Now, I set up a limit in there so that you had to be so close before you could set up a phone link. Let's suppose for a second that I go back and I change the parameters just a little bit. I'm going to say that I've got 5 people that I'm dealing with, right? And I'm going to go back in here and I'm going to disable some of this stuff that did all the neat stuff with it. So I'm going to go ahead and take, I'll take this off. We'll go ahead and we'll take this off. We'll go ahead and we'll take this off right here. Okay, so now they have no way to be able to set up that link to each other. That's part of the inherent behavior. As we were learning to build these dynamic models and make these things move around on the screen, I asked my students, I said, let's pretend for a minute that you are some kind of an all-powerful being. And you're going to create a world that has beings in it. What kind of properties would you give to this being so that it had a form of intelligence to it? And we talked about relationships, and we talked a little bit about how do you simulate fear, how do you simulate attraction. These are all things that are going to fold into artificial intelligence, which is coming more and more to bear within our fields, our engineering technology. We're working with more and more systems now that have artificial intelligence to them and that are assisting us in making some of the most important decisions that we have to make about our design process. So that's kind of where the technology part comes into it, because if we're going to think about making a dynamic model like that, we have to know a little bit about how people act, but you got to know a little bit about how to work with technology too, that way. What do we got here? We got about 9:30-ish. Let's flip on over to Rhino here for a second. Pop this one up here for you. I love Rhino. Rhino is a great piece of software. When CAD students come to me from the high schools, or when I talk to them out the high schools, a real common question I get is, what's the best CAD software? And I say, wow, what a great question. The best CAD software is the one that does what you need it to do. But I tell them, if I were stranded on a desert island, this is probably the software I would have with me, because it allows me to do a lot of different things. The Rhino software allows me to be able to do surface modeling. It allows me to be able to do solid modeling. It allows me to be able to do conceptualizing. It allows me to be able to do stretch outs. It forms a basis for being able to do 3D printing. There's a lot of stuff I can do with it. For a time out in industry, I worked as a CAD technician. That lasted for about 2 years. And then one day the boss came in and said, congratulations, slaps me on the back, you are now going to be a designer. I said, wow, can I do that? Yeah, you can do that. You can be a designer for your company if you know about the process, you know about the materials, you know about the specifications they use. You're qualified to be a designer. So I got promoted to designer. And very quickly, I realized that as a design person in engineering technology, there are a lot of questions that are not answered for me. And I'm not brilliant. Like I said, my skill set when I got out of college was good. I was an average student. But I found out very quickly that if I understood my technology it helped me answer some of the more pressing questions that I had to deal with. Let's take a look at an example of this one right here. I'm going to go ahead and pull up another piece of software that's going to run on top of this that's called Grasshopper. Now, those of you that have worked with Lego Mindstorms, this is very comfortable for you because it's what we call visual programming. What you do is you pull out these little blocks, you drop it in, and then you specify within the blocks what the behavior is supposed to be. And then you create relationships between these blocks so that they can exchange data together. So what I did was I said, hey, look, there's a curve right here. And here's another curve again. So I got two of them. I want you to take one of the curves and I want you to move it back and forth horizontally like this. Now I'm going to show you. So I'm going to grab the slider. So I can take this thing and I can go ahead and move it back and forth like this, dynamically adjusting it, which designers, we love that. Because if we don't have the answers given to us, we have to find the answers. And very often we have to do that by looking at different scenarios. So the other curve is just sitting still. And then I said, look, if they overlap each other, can you show me where that overlap is at? And it's at football right in the middle. Now, I had mentioned hydraulics a little bit earlier. For a while, I worked within a company where we designed hydraulic systems. And what we would do is we would have the hydraulic fluid would go through a hole. And that hydraulic fluid creates this pressure that will push on other objects. You have to have a lot of respect for hydraulics. I mean, you're talking thousands and thousands of pounds per square inch. And we would have another object that might have a hole drilled through it. And maybe there's no fluid flowing through at this point, but when they start to overlap each other like this, it creates a football shape where some of that fluid can get through. And we can regulate the flow. We can say, I want a lot of flow through there, or I want very little flow through there. As a designer, sometimes I wanted to know specifically what that area was of that football. So in this simulation right here, I said, go ahead and measure the area of the football. Tell me what it is right now, and it's 2.128. And then I told the model, look, I want it 1.375. So what the model does is the model compares the actual area to the target area, the area I want, and subtracts. How much is that right now? Let's find out. It's 0.753, but it's a negative 0.753 because I said subtract this, or excuse me, subtract this from this. And then I did kind of an old computer trick. I said, just go ahead and find the absolute value so it's never negative. And then I introduced this little bugger in here. Now, this little bugger is called an evolutionary solver. Really cool stuff. What it does is it goes out and it walks along a landscape, kind of like walking out into your backyard. And if you can visualize, the higher spots in your backyard are good answers. The lower spots in your backyard are not great answers. And what an evolutionary solver does is it walks along those valleys and mountains, keeping track of the height of each mountain. When it stumbles upon a mountain that seems to be higher than any other mountain, it says, that's it. There's your solution. So I'm going to go ahead and double click on this. And I'm going to go ahead and run the solver, but I'm going to show you all the solutions as they work, okay? To see what's happening, sliding it back and forth. And it's doing that by automatically adjusting for me. I don't have to try to slide it. There's no guesswork. I just told the model, you go ahead, you take care of the process for me. I'm going to go get a drink. I'm going to get my morning donut. I'm going to talk to the boss about what we got to get done today. And then hopefully by the time I get back, there's going to be some kind of a solution that I can get from you. Now, bear in mind, a very important principle about engineering technology is that technologies do not solve problems. They don't do that. What technologies do is they present solutions, but it's up to us to be able to look at the solution and decide whether or not it's a valid approach. So I go ahead and speed this up, and it's done at this point. I'm going to go ahead and click OK. And the model now has settled on this spot right here. And it tells me that the actual area of that football is 1.3749. I'm going to say close enough. That's great. And all I would have to do now as a designer is I would have to measure how far it is from the center of this hole to the center of this hole. And we're off and running. I know exactly what I need to do. I guess maybe one more thing we can kind of talk about. Let's go ahead and take this off for a second. you know, companies like Nike, companies that deal in medical prosthetics, companies that deal with boats, airplanes. Making 3D models of those is not as easy as it seems. If all I have to do is create a pop can, a good way to start is to just go ahead and make a cylinder. So I can stretch it out like this, pop that in. I can go ahead and pull that up a little bit. Let's go ahead and shade this so it helps in the visualization. Okay, that's the start of it. Now I'd have to go ahead and do more work with it. But sometimes when in engineering technology, when we deal with challenges, design challenges that are not so nicely behaved, we have to get a little bit more creative about our solutions, and we need the right kind of software to be able to do that. So let's take the example of the boat real quick. So I'm going to go up to solid, and I'm going to choose sphere and center radius, and I'm going to go ahead and choose like this. I'm making this big old sphere. Okay. Then what I'm going to do is I'm going to go up to edit, and I'm going to tell it to turn on the control points. Now, what are control points? Well, control points are handles. When you put on a shirt in the morning, you grab the shirt at the bottom, you pull it over you and pull down like that. Where your hands grab at can be thought of as control points. So I'm going to go into the front view here, and I'm going to go ahead and circle all these, and I'm going to go ahead and pull these control points down like that. And you can see what's happening here by looking at this. Is what I'm doing is I'm dynamically shaping this. And this is a very, very common way that we do freeform modeling. So I'll go ahead and take the front of that, pull that out like that. I'll go ahead and take the back of that and pull that out like that. And then from there, we can go ahead and continue to work. You can work on the hull and try to add in a little bit more as far as the hydrodynamics on it and whatever you need to do with it. But that's the basic process. When you do freeform modeling, we take some of the most basic shapes and then we transform them using some kind of fun, kind of advanced types of functions. And we can go a lot of different ways on this. There's one more I'll show you real quick, and then I want to give you time to ask questions if you need to. So I'll do solid. I'm going to do a box corner to corner height. I'm going to pick right here. Let's go ahead and let's take this thing and kind of stretch it out. Let's give it some height. Going to pull up like that. Okay. What can we do with this thing? We could maybe let's do a twist. Twists are cool. So I'm going to go ahead and select this box to twist it. Started the twist axis will be right at the bottom. And then let's go ahead and pull straight up in the air. So I'm going to try to hover just above the top here, right there. I'm going to pull this little crowbar out in the top window. And then I'm going to start leaning on that crowbar. Okay. And with the right amount of twisting on there, it's fairly easy to create threaded features. You'd have to do some trimming on the ends, things like that, but yeah, pretty easy to do threading. So buttoning all of this up, I told Megan, and Megan knows this, it's every time that we try to describe engineering technology, it's a very big job. There's a lot to show, and you can never quite show enough about it. That's the thing. There's always more and more cool things. If I have more time, I could show you how we resolve a situation in an inner city where there's traffic jams all the time. We can build a model of the traffic pattern, and then we can go ahead and build extra roads, simulate that and see how it affects the flow of traffic. We can simulate a wildfire burning through a forest and check the rate at which it's burning through and when it's expected to stop burning. We can create air defense systems, and we can show it shooting down the planes. We can run a simulation and see whether or not it would be effective in its placements or if we'd have to move things around. So yeah, it's a pretty important thing. I mean, when you get in the design process, this is a pretty important part because we have to get things from here over to right here. And I tell my students all the time that, you know, it's not about understanding everything about one software. It's about knowing enough about a lot of different software so you can find ways to go ahead and combine them together. A couple things real quick. I just want to, as long as I have you all together, I just want to do this real fast. We do have a Facebook page. It's an old Facebook page, and I haven't posted on it in quite a while. And the reason for that is that I've been designing our new Facebook page, and that'll be coming online pretty soon. But for the time being, if you go to facebook.com Triton CAD, I think that will give you a better idea of all the different kinds of things that you can do in engineering technology. And I've got lots of different kinds of examples on there. I even got some videos of myself teaching different lessons. So if you want to watch those, you can see some other things that we do as well. Okay, 9:40. I guess we'll go ahead and we'll take questions, huh, Megan?
Sure, yes.
Okay, so what kind of questions do we have that I can help answer for you?
You can go ahead and unmute yourself, or you can use the chat box to ask questions. Neil, I'll start you out with a question. One of them I was thinking of, how long does it take to navigate and to learn the software that you were just showing us?
All of the softwares?
All of them, yeah.
In the 2 years that, and I'll speak for Iowa Central specifically, and then I'll talk about other colleges, but specifically at Iowa Central, you learn 6 different softwares in 2 years. And you won't know everything about every software. You're going to know about 2/3 of every software. The people that need to know more than that are usually motivated enough that they go on with tutorials and they learn everything else they need to learn. What I do is I teach the most important 2/3 of those 6 softwares, because those are the ones that you are likely to encounter out in industry. And when I worked out in industry, I got laid off several times because of economic cycles. I found out the hard way that if you only know how to run one software, you're a target. So when I took over the program, one of the things that I insisted on was that my students were going to know multiple softwares so that they would be the last ones to be laid off. Typically, at most community colleges, you're going to learn 2 or maybe 3, possibly. Some colleges will take the approach where they say, you know what, we work with the same companies all the time. We are going to teach you Creo, and you're going to learn everything about it and learn no other software. That's a valid way to approach it. If your students are going to be getting hired by the same company, great. Here in the 9-county area, we have a wide scattering of companies that have different needs. This is the way I choose to approach it so that students have the best shot at getting hired. But I think every engineering technologist should learn at least 2 to 3 softwares.
Awesome, good answer. It looks like we have a chat from Allison. Let's see here. How marketable is a degree in this area? And Neil, you can probably see the chat too, so you can answer that question however you want. But what are some specific places that would employ someone with this degree? Earning potential. Okay,
great questions. Yeah. The problem I'm having right now is companies keep coming looking for students, and we don't have enough. We just don't graduate enough. And the problem is that CAD programs are not that popular at the high school level for a number of reasons. Sometimes teachers don't have training in CAD software, so they don't offer the classes. The startup costs sometimes can be a little bit problematic, but now we've switched to using cloud software, so it's a lot easier. If we could get that number up and start getting more people graduated, there's jobs out there. I just got contacted by 2 companies that I don't have anybody to give them right now. So what I'm doing is I'm searching through graduates, trying to see if anybody's looking for work right now so I can get them paired up. So marketability is not an issue at all. It's the opposite problem. Specific places that would employ, not knowing what high school you're from, I'm going to say, over in Storm Lake, we have Meridian has hired quite a few of our people. Up in Humboldt, Chandler, high capacity. Over in Webster City in the past, we had a bit of a downturn in Webster City, but places like Vantech or Mitchell Machine or, well, it used to be Beam Industries. I think somebody else is in there now. It depends a little bit on what community you're in and how far you want to travel, but we do have them in the 9-county area. And the companies that call me are from, I think I got one from Ida Grove right now, and I've got another one from Spencer, I think. I have to go back and take a look at that. Earning potential. What I'm hearing from my graduates is in the neighborhood of $15 to $22 an hour, depending on who you get hired by. It usually is a little bit better pay in an economic cycle where it's hard to get people hired. So the pay is usually better. There's a lot of opportunities to move up. You usually spend about a year or two being a CAD tech, and they're going to grab you and say, come on, we're going to turn you into a designer or an engineer or whatever. A lot of companies will pay for extra schooling. So there are some good benefits with it. But I'm going to say right now up towards about $20 an hour.
And then it looks like we have another question. Is this a job that I could do from home?
Yes, you could do that. Your startup costs are a little bit tough because you have to have a very good computer. That's going to cost you anywhere from $1,000 to $2,000. And then you have to have a commitment to some kind of a software that you know other companies will be able to work with. AutoCAD products are always a good bet. They usually will play nice with other software. So if you're a freelance person that's going to do this kind of work, you really need to do your shopping and try to figure out who your customers are going to be. Try to learn what softwares they use, and then try to select your softwares based on who you're likely to work with.
Awesome. Thank you, Neil. Okay, we're going to go ahead and move on to the next presenters. Neil, thank you. That was very, very interesting and way over my head. So I learned a lot. And then Neil will be on for the remainder of the time. So if you guys think of other questions for Neil, please do let us know. You can put them in the chat, or at the very end, we'll give you an opportunity. And then also, like he said, you can definitely reach out to him too. So the next presenters are Jenny and Julie. So you guys go ahead whenever you're ready.
Hi, everybody. I assume there's real people out there. I am Julie Ersman, and I teach biology here at Iowa Central Community College, and I've been here for, I don't know. Hey, there's Emma. I've been here for about 15 years, and I had a career in science, so I'm just going to speak just for a minute about that, my experience. And I did teach high school biology as well. So, and I will just tell you, there's a huge demand for people that go into science. It's just, just what it is. There's always a high demand. And so the job that I had was working in a lab. I worked for a company that made vaccines for animals. And so my job kind of fell into two sort of categories. Part of my week, I would go out and collect blood samples from the animals, cats and dogs mostly, and collect those samples, and then I would bring them back to the lab and do testing on them to see if they had immunity to what we were vaccinating for. So I just brought a tool, a really common tool used in a lab. It's called a micropipetter. I don't know if any of you have seen something like that. If you watch, crime shows like, I don't know, CSI or something like that, and they show you the lab, they sometimes will show you somebody operating one of these. You put a little tip on the end like this, and it's just a tool to measure liquids. And the tool that I have here measures very tiny amounts of liquid. So I'm just gonna demonstrate how it works and try to show it to you. So I just have a red or green food coloring in this little micro tube. This is another tool that's used a lot in a lab, just small little tubes, because we deal in small amounts. And I'll just show you that I measured up about 10 microliters, which is a very small amount. So this is 10 microliters. If I had maybe like 100 microliters, it would be about the size of a drop. So just to kind of give you an idea. And then if I want to deposit my solution in here, I just use my micropipette to do that. And I'll just kind of try to show it to you. You can see it's just the tiniest drop on the side of that tube. So that was what I spent a lot of time in a lab doing. I really enjoyed my time in the lab because it was nice to work in the lab with humans sometimes, but then it was also really nice to get out with the animals and spend time with them. I'm super allergic to cats, and I found myself with a lot of cat projects, which was a problem, but the animals were kind of a nice diversion. And so anyway, that's my story. And then I'm going to hand it over to Emma here in a second, but I will just tell you that among the biology teachers here at Iowa Central, we most of us had a career outside of teaching first. And so I just wanted to throw out to you that if you're interested in veterinary medicine, for example, my coworkers or has an office right next to me. She came here and got a 2-year degree from Iowa Central and went on to UNI and then went to vet school. And she's a great resource for just discussing vet school. So, and we're all super willing and able to have a conversation about any of these topics. We have another instructor that was a chiropractor. We have myself, I worked in a lab, and we have another instructor that worked in doing research around plant biology. So if you have any specific interests, you can always contact our admissions people and they can try to hook you up with one of us if we can help out in any way. So at this time, I would like to introduce one of my former students, Emma Simpson. She took biology with me a couple years ago, and she has gone on to graduate school now, and she's just going to tell you a little bit about herself and her experience and maybe some of the opportunities in the scientific field. So I'll throw it to Emma.
All right, so yeah, my name is Emma. I originally went to Iowa Central. I graduated high school in 2016. So I went to Iowa Central for 2 years. And that was a great opportunity. I was able to kind of be involved in multiple things. And I got to take a lot of my biology and chemistry courses there, which was a great opportunity for me. I then transferred to the University of Northern Iowa. And there I got to partake in a lot of undergraduate research, which was pretty amazing to get involved with. So the first research project I did was our summer undergraduate research program. And what I did for this research program was we were restoring prairies in Northern Iowa. And so we were doing this under the Farm Service Agency and the USDA. And basically, we were looking at kind of whether these restored prairies were actually allowing pollinators to return to that area. And so we were not only analyzing kind of vegetative structures, but we were also looking at pollinator counts and the kind of different species that were involved there. We did this by doing transects of the vegetative variety. And then for our pollinators, which is what I was mostly involved with, we did a lot of sweep netting for bees. And that was great because I actually was able to turn that into a secondary research project. I actually helped start a lab at UNI under IWEN, and she and I were using the bees from our pollinators in the prairies, and we were going to start a population genetics study. So I am actually in grad school now, and that is my main thing. I really like population genetics, and I'm starting to do epigenetics as well. So that was really cool. But I started this lab with and we were basically extracting the DNA from bees and kind of figuring out the best process of how to extract the DNA and to analyze this DNA. And so I was involved with a lot of preliminary research at this time. And that was a really cool side to see because I wasn't necessarily involved with that with my other project. I was doing a lot of field work and a lot of analyzing data, but I wasn't really part of that preliminary research of how we're going to start this experiment and what we're going to look at and how everything is going to work. And so I got to write grant proposals, and I was accepted for these grants, and it was amazing opportunities while at UNI as well. And I only got those opportunities because of the success that I had at Iowa Central. And so Julie actually kind of got me on my track for population genetics. We were taking just the normal general biology courses, and I was originally thinking about doing I was still on the track of genetics, but I was originally wanting to do a genetic counselor position, which is basically you're working with humans and kind of analyzing what kind of, maybe if there's some genetic markers that you're wanting to be looking for, whether that be for an adult or for a child. And after taking that class and like kind of looking at some conservation biology topics, I really realized that I was mostly passionate about population genetics in the conservation field. And so that's what I'm working with now in grad school. I'm working with Dr. Aaron Schrei, and we are analyzing the Florida sand skink and the blue-tailed mole skink, which are both endemic to the Florida Peninsula region. And basically, we're taking snippets of their tail and we're kind of analyzing their population structure. And then we're also looking at their methylation status and kind of that epigenetic realm of what's going on and what is causing stress in that environment. So, I mean, yeah, that's a little bit about myself. I would love to take any questions with, you know, anything to do with undergraduate research or how to get involved in research. Does anybody have anything they want to ask me?
Hey, Emma,
Yeah.
I know from Julie that you were really involved at Iowa Central. Can you
Yes.
tell these guys any advice you would have for them as far as if they should get involved or how to do that, and like what sort of impact that had on your overall kind of college trajectory?
Yeah. So I like to stay busy. So I have a hard time just like sitting down and not doing anything. I know that's not always the normal trajectory. But staying involved is really, really important, especially when you're transitioning into college. In high school, you tend to have that built-in community from friends you've known since you were in preschool. In college, it can be different. You're in a new environment, you're in new places, you don't necessarily have that built-in friend group. I was involved in dance. I was on the dance team for both my years at Iowa Central. I was team captain for both years. I was also involved in work study, and that was really great. I had some science teachers that I could make connections with through that. And even just some kind of outside groups. There was some like the athletes, I can't remember what it's called now, the kind of religious groups that are with athletes. And that's kind of helpful because you can not only talk about things outside of school, but you're with people who might share similar interests as you. All of those things are super great, especially as you're transitioning to a new environment. I really think staying busy helped me a lot. It really required me to manage my time wisely, which is a super important thing in grad school or any kind of secondary school you're going to. Even just going up your years in university, you know, you're having classes, you got to manage research, you might have jobs. I was also working at this time. And so managing that time is really important. It's always important to have a social life, but some of that social life is built into the groups and communities that you're with. Yeah, does that kind of answer your question? Anyone else?
Awesome. I have a couple questions for you. One that I wrote down here was, where do you see yourself in 5 years? Because you sound incredibly intelligent and you have a lot of goals that you've reached so far, and it sounds like you are continuing to do that. But job-wise, where do you see yourself?
Yeah, so I've been thinking a lot about that this semester. I have always wanted to do research. I am definitely one of those students that I would love to just learn and learn and learn. I'm always just wanting to take classes and courses and things that probably don't even need to take, but I want to. And so if I could stay in school for the rest of my life, I probably could, but obviously that's not a thing. But I've been talking with my advisor, and he's a great mentor, and just talking with teachers from the past. I plan to go to PhD school, get my PhD, hopefully in the realm of epigenetic conservation and genetic conservation, but I'm not completely stuck on that. As long as it's with genetics and epigenetics, I'm fine. That's my main goal. But basically, this semester, we're really looking into ways that I can get into a PhD program that is going to be what I want. I have had a lot of opportunities here and I have worked extremely hard. So I am fortunate enough to be able to kind of be choosy about where I want to go, which is something that's not always the case. I did end up here and I wasn't sure because it was so far away. Again, I'm in Georgia, so like it's a huge change. But since I've been here, it's been extraordinary. I picked here because I really, really loved the advisor that I was going to work with. I felt like he was great at communicating with me, and he had the research I was interested in. Sorry, I got a little bit off topic, but so I just think for anyone that's wondering about where they see themselves, to kind of trust that gut instinct. And so my gut instinct is to get my PhD. So that'll take me, another 3 or 4 years after this. But then I just want to continue to do research. So I've looked at potentially becoming an assistant professor at a university on that tenure track. I've looked at a couple of labs, and as much as I love them, sometimes doing your own research kind of surpasses doing other people's research. So that's something I'm trying to keep in mind on whether or not I want to do kind of my own research at a university and teaching with that, or whether I want to be a part of a lab.
Thank you. Did you see
Yeah.
the chat question from the student? There's a student wondering the workload. What's it like at the science area? for school?
So workload, I would say in the science, it depends on, I would say, what track you're going for. If you're going to do a BS versus a BA, there are some differences. I wouldn't say it's a huge difference. Basically, you just take 1 or 2 less classes. I was originally on the BS track, but instead at UNI, I decided to kind of, instead of going through a general biology program, I actually joined the ecology, evolution, and organismal program. And so that was kind of just a smaller subset. So I was actually able to take more classes that were going to fulfill what I wanted to do in the future versus just general microbiology classes or things that necessarily weren't in my track. So I would say my workload was not impossible. I hold myself to a standard of pretty high standards, but I never seem to have an issue with getting work done as long as I managed my time wisely. I had a job. I still have a job. I've never had any trouble working and getting my classes done. I would say if you're having issues with the workload or you feel like it's too much, just like almost giving a list to yourself every day saying, what's the most important thing that needs to get done today? And then just get that out of the way. I am very anal retentive, and so lists are a big thing for me. I make weekly lists, I make daily lists, and it's really helped workload wise for me. Undergrad is a little bit different. I would say the workload from undergrad, if you're until going into a secondary school, it's kind of like going from high school to college. There is a transition there. But undergrad, it was, as long as you're involved in things that you want to be involved with, the workload is never really that much of an issue.
Good advice. Thank you. And then one more, it looks like I just got, let's see here. What other advice would you give students interested? So if they're in high school, which that's your audience today, maybe what classes should they take? Should they job shadow, do an internship? What did you do, or what do you think would help them?
Yeah. So in high school, it's a bit different. If you have the opportunity to take college courses in high school, like especially some of those prereq classes like composition, like psychology, all of those undergrad required courses, those are great to get out of the way in high school. Like senior year, I was able to take courses through Iowa Central. I was very fortunate that my school had program that allowed that to happen. And so I was able to take, I believe, 3 classes of college credit courses in high school. And that really freed up a lot of my time at Iowa Central. So I don't believe I ever took more than 16 credits a semester. I really advise around that time. Sometimes if you get all the way up to 18 or 19 credits, it can be a lot. So I would definitely say try to get college credits out of the way. That's not always possible. So if you could take classes that would benefit you going into college that you'll know you'll have to take, if you could take like a physics course, or, you know, some of that upper level math. I know a lot of seniors in high school, they don't have to take a 4th year math. But I promise you, when you get into college and you have to take a math class and you've not had math in over a year, it can be very, very stressful getting back into that realm. So I always advise taking a math class that senior year. And if you have a high school teacher with a master's degree, you can take college credit for that math class if it is an upper level math class. So I always advise taking a math class, taking as many classes as you can for college credit senior year. I did not get to job shadow my senior year, but I did actually shadow professors at Iowa Central my senior year. It was for a class project. I came into Iowa Central and looked, I emailed a couple of science professors and asked if it was okay if I came in and observed their classroom for the day. This was to kind of help me figure out what I wanted to do. In high school, I was kind of a veterinarian route too. I have since learned that I am too empathetic towards animals for that to ever have been a good thing for me. So that was great because I took an animal course in high school and we had a veterinarian that was helping with that. So I got to talk to him. So taking classes, observing classes even that you have interest in is always key, because you can say, hey, I don't really want to do that for the rest of my life. Or you can say, hey, that's really cool. I want to do this. So always do things that are interesting to you. And math class that 4th year, I tell you what, it'll help you.
Wow, great advice. Thank you so much, Emma. Is there any other questions for Emma? You have so much energy. I love it. No other questions? Okay, we'll turn it over to Jenny, but thanks again, Emma. We appreciate you taking the time to talk to us.
Yes, I'm going to run. I have some research to do today, but it was really nice chatting with you guys, and I hope this helped.
Thank
Thanks,
you.
Emma.
Take care.
All right. Hi, guys. I'm Jenny Gernhardt. I also am an instructor here at Iowa Central for the science department. I won't talk to you much right now. I want to just introduce a former student of mine to you guys, and I'll talk to you here at the end when we wrap up. But I actually have invited in Kylie O'Leary, and so I'll let you guys get to know her in a minute. I'll have her tell her about herself. She, just to give you a little bit, she started out at Iowa Central, got her nursing degree from us, has gone on to get her BSN. And she has all kinds of information. I think that you guys will find she and Emma are pretty similar with that energy and involvement. So any questions you have, throw at her. And otherwise, I kind of gave her a list of stuff that I thought you guys would be interested to hear about. So Kylie, it's all you.
Hi, Jenny. Thanks for inviting me today. So I'm Kylie O'Leary. I got my nursing degree, my RN, through Iowa Central. Before I went to nursing school, I actually went and got a bachelor's degree in athletic training. Worked for a couple years in that, enjoyed it a lot, and then decided that maybe that might not be the best long-term goal for me in regards to starting a family and being home. So I decided to go the nursing route. Got my RN, graduated, went on to work, started online for my BSN through Chamberlain University, completed that, and now I'm working on my nurse practitioner through Chamberlain right now. So married, I've got one kid, a daughter, she's 6 months old. It's pretty much all about me, that's all I got. you have any questions specifically, Jenny?
Well, actually, I pulled up some of the questions that I had sent to you to thinking that students might want to hear.
Okay.
So first, I want you to get to talk about your college career too, but will you tell them a little bit like what a typical day is like for you then, so they have an idea of what someone with a BSN does and you know what's good, what's bad, you know, so go through a typical day and then tell me the things that you like the most about your job and then the things that are more of a challenge.
Sure. Well, with COVID, nothing is normal anymore. As you can tell, my energy level is a little different than what it used to be. But pre-COVID, my job is I oversee independent and assisted living over at Friendship Haven in Fort Dodge. I enjoy it a lot. I've worked in a lot of different settings in nursing. I did med surg, I did neurotrauma, ICU. I've been kind of all over the place. This has just been my favorite. I love old people. They're my favorite. My typical day would be I come in, I check on everybody to see kind of what's going on. It is a lot of paperwork, more so than previous. I do a lot of like blood draws, lab work, communication with physicians, a lot of that kind of thing. My current position is like a Monday through Friday, so I'm able to go home in the evenings. So that's nice. Previous jobs are 12-hour shifts. Typically, you work 3 days a week. So that's kind of nice. I mean, there's quite a variety in nursing, so there's really no limits there. My favorite part about my job would probably be hearing the stories. I get to spend a lot of time with people and hear about their histories and things that, you know, they've experienced in life that, you know, we have no idea. And so that's always really interesting for me to hear. The worst part probably about my job is being a supervisor. Holding people accountable isn't hard for me, but when you get through that progressive discipline, that's kind of where I don't enjoy my job the most. But you got to know what's best for your patients or your residents, and that's just how it is.
So you mentioned a little bit of this as far as with your previous jobs, but the next couple questions that I had, and then in students, if you guys have questions, if you want to ask them or put them in the chat, I'll switch to that. But otherwise, I'll kind of keep running Kylie through our list here. Can you tell me more and tell the students more about varieties of jobs within nursing? And then even if you can think of, because I think that you've been in a hospital and nursing home setting, if you can think of careers maybe that aren't nursing, but are similar for science-minded people. So what are the varieties of things these guys could maybe do if they pursue science?
Okay. So nursing, the best thing about it is with a nursing degree, you can do just about anything you want. It ranges from being a teacher in a teacher setting, a school nurse. You can go on and be a nurse practitioner. You could be in surgery. There's endless possibilities. And with an RN through Iowa Central, a lot of those doors are open. And then getting that BSN, that second level, only opens more doors for you. If you're looking for more of a supervisory role, a lot of those typically are bachelor degree nurses. I know a lot of hospitals are now requiring that, or they say, we'll hire you, but within so much time you need to have it. So there's quite a variety there. A lot of science type jobs that I work with frequently, I would say, is like radiology, med techs, pharmacy, things like that. A lot of physical therapy, occupational therapy, speech therapy. Those are probably who I work with the most that are in the realm of nursing, but if you're not into blood or anything like that, that would be a good route.
So you've told us a little bit about your career, just to make sure, guys who are watching this, that when she says BSN, she's referring to that bachelor's level degree. Although Kylie, you did work for a while just with your associate degree, right? Your 2-year.
I
as
did.
well?
I actually completed my LPN first and worked for a while and then went back for my RN. Money was just something that we needed. And so I worked as a CNA before I became a nurse. And then I got my LPN. I worked for a semester like crazy so I could pay for the next semester and then paid for the next semester. And then when I graduated, I started working right away after that. And then took a couple months and then started online for my bachelor's. I didn't take too much of a break.
So another question for you. Can you tell a little bit about, and I know that you can only speak to maybe to local to Iowa, but you might know from friends. I know I hear from former students. Can you talk a little bit about what the pay and benefits might be like, what they could anticipate?
Yeah, so it's kind of a double-edged sword. A benefit of nursing is job security. You're always going to need nurses. You're always going to need healthcare. So you don't have to really necessarily worry about losing a job and not being able to find one. So that's nice. They say nurses make great money. They do okay, but for the things they do, I feel like we could probably use more, but who couldn't, right? Depending on your job, if you're hourly, typically as an LPN, you make anywhere around the $18 an hour range. As an RN, you typically make around 22 to 28 probably an hour, in that ballpark. If you're in a salary position, you can probably expect right about 50,000 a year plus, depending on your experience. Some jobs do pay more if you do have a bachelor's degree. And then if you decide to go further, nurse practitioners, you can kind of see more into that 70, 80,000 plus range. That's Midwest numbers.
I like that you mentioned that's Midwest numbers. Yeah, because it can range depending on where you're at. But yeah, for here where the cost of living is low, it's pretty good. Although my mom is a nurse, my mom's been a nurse for my whole life. So I will say that nurses do make good money, but they work really hard for that.
Yeah. I love your mom.
And she loves you. That's funny. So my final question is just more general, which is, can you think of any advice that you would give for students who are either just considering a nursing career? Because I know you personally, I know that it was a big progression for you, like the pathway, to decide what to go on. So thinking back on that, what advice would you have for these guys who haven't started yet, as far as when they're starting that career and how to decide what to do?
Well, with nursing, it's always something I wanted to do. Honestly, I just didn't think I could do it. I said, math and science, no, thank you. The coursework is too much, biology, and yeah, I can't do all that. So I'm going to go a different route where I can kind of avoid all of that. Truth is, guys, don't waste your time. If there's something you want to do, you're going to end up doing the work that is worth it. And nursing school was hard. It was not easy for me. I got an entire bachelor's degree and didn't study at all, and then went into nursing, and holy cow, did I get my socks rocked. But if you put in the time and realize that your current situation is temporary, the time that you're spending, the time that you're giving up with your family, with your friends, is temporary. And what I always said is, by doing it this way, I'm able to spend more time with my daughter and give her more things because I did this first. And I just took the time, buckled down, and did what I needed to do. And we've been very fortunate because of those decisions.
I was hoping that you would mention something along those lines. Yeah, because I agree. You should go where your heart tells you to go and figure it out. I think too many people get scared off of like math, science, engineering careers because they think it's going to be hard. But as someone who, when I was a single parent when I pursued all of my degrees, so I was up every day at 5 a.m. studying. But it's made it to where every day of my life is joyful, you know, so do what makes you happy. Thank you, Kylie, so much. So are there any other questions for Kylie before I just have one brief thing that I want to share with you guys too, but I want to make sure students' questions are answered.
Thank you, Kylie.
You bet.
Megan, am I good? I don't see anything else in the chat yet. Okay.
Yeah, go ahead.
Thank you so much, Kylie. I'll follow up with you later today.
Sounds good. Thank you, guys.
Yeah. So just to share with you guys a little bit. So I have taught here for Iowa Central for about 10 years, but I wanted just to kind of, before, you know, we just have a few minutes left here to kind of summarize what you've heard from myself, from Julie, and then from Emma and Kylie, both people that we spoke to. I want you to think about just the sheer number and type and diversity of careers that you can do within science. And what's cool is that you can do those things with an associate degree. You can do them with a bachelor's degree. You can go on and get a master's degree or a PhD or MD. And at all of those levels, there is a big want for people with a science background. So, and one thing for me, where Julie said she worked in industry, you know, she worked in a lab beforehand, and that she came to teaching later. And we have a Dr. Ann Mossick-Lackalt is the veterinarian who then works with us now too. For me, I always knew I wanted to teach, you know, so I came in knowing that I wanted to get a graduate degree to work with people like you guys. So there's just a huge variety of how people end up in their science jobs, but there's room for all of us. So things like nursing, nurse practitioner, which is kind of like getting to see patients one-on-one. So similar to an MD without quite as much school, doing anesthesia, pharmacy, Emma talking about her population genetics, anything with the environment. If you care about what's going on with the climate, there's tons of jobs for you. Trying to think of what else some of my students and friends do. I have actually one of my friends from graduate school is an animal trainer. So like she worked with whales, she worked with primates. She currently works at a wildlife rescue in Mississippi. For a while, she worked with one of the only primate. So think of like apes, right? Or organisms that are very similar to us. She worked with one of the only rescue facilities in the nation where she was literally out talking with, interacting with primates, which is pretty cool. But there's a huge variety. So as much or as little school as you want to do, there's something for you to do. So just to show you, if I can, I'm gonna share my screen here with you guys. Hopefully this will work. I've got it geared up in the background, but just to show you something that I do on the side. Primarily I'm a science professor. I teach biology and microbiology, but I always loved English. And so I think that we forget sometimes that if you have things that you like to do that are outside the realm of science, there's still room in science for you. If you are an artist, there's always room for like all the online projects and textbooks and stuff to have people who are science minded and who understand those processes, but who can draw. Those people are really valuable. Or if you like some of the stuff that I'm guessing, I guess this might not be quite Neil's stuff that he did with you guys, but like computer programming stuff too. So what I'm going to show you guys is a current project that I do on the side here. So this is with a company called Norton, right? It's a textbook publisher. So one of the things that I do is author questions that then go out to students, and then a computer programmer would go and take the questions that I've written and put it into code so that you can see you can see them on this cutesy little website. So I'll show you what I do. So I get these little templates that I have to do, and I have to fill in these questions, and I have to use this certain way to put them in, you know, where depending on if I'm using brackets or an equal sign or something, it has different meanings to the people who code it. And then eventually though, what it looks like is this. So I'll show you. I'm going to do it in a mode, I think, where you don't have to hear a bunch of the music in the background. And so there's these Let me find an easier question maybe that you guys might know the answer to. I picked a too hard a chapter. Yeah, maybe we'll leave it at this one. Okay, so I'm just curious if any of you guys, and I don't know how many students have their own access to the chat or if it's instructors, or maybe if Neil and Megan want to try to answer, which process is responsible for the air that we breathe? If any of you are brave enough, pop a question or pop a response into the chat thread. I always say you can always respond to me privately because then no one else knows what your guess is. Neil's thinking about it. No, no one's brave enough to take a guess. All right, fine. So here's what happens. So then when you click on these options, it's going to tell me it's not correct, right? Not correct. And then ultimately, hopefully a student would land on that it's going to be something with photosynthesis. And then it'll tell me that that's right. And so in order to do that, someone like me who just has this background in science, I would write the question and then I would use coding and use a little equal sign to where they would know that the photosynthesis was the right answer. And then someone on the more computer side would have to go in and code that to make that light up green and to make it appear the way that it does. So if you like computers or if you like anything with art, there's jobs within that for scientists as well. And sometimes we forget about that, but they span so many different careers. There's just always room for science degrees. Anyway, that's it from me, unless you guys have other questions. Let me stop my screen here.
Thank you, Jenny. Does anyone have questions? Looking pretty quiet for questions. Okay, well, if you think of questions for Jenny or Julie, do let us know. You can put it in the chat or you can always get a hold of us at a different time. Neil was writing.
Yeah, and he's right. There's such a blending between the fields for sure.
Awesome. Thank you, Jenny. Appreciate it. Take care. Okay, last but not least, you ready? We're going to hear from Thad now. Thad, you let me know when you're ready. Do you want to show your video first?
Yeah, let's just go ahead with the video first.
All righty. So let me share my screen here. Okay, Thad, can you see my screen?
I can see your screen.
Okay, let me know if you can't hear it. Oop, can you hear it? No?
No audio.
There we go. There we go. Okay, here we go.
My name is Thad Cooper. I am the coordinator for the Industrial Robotics and Automation Program at Iowa Central Community College. I graduated from a two-year college. I have an Associate of Applied Sciences degree in Electrical Technologies. And for 15 years, I worked in industry. The program has only been around, this is our 6th year. Right now, we have about 10 students. And the program itself is 2 years. If you start by enrolling in the robotics program itself, it's a 2-year program. If you take the Electrical Technologies program for 2 years, you can come back for 1 more year and take a handful of classes and walk away in 3 years with 2 2-year degrees. So the classes that I would recommend would be classes dealing with AutoCAD, for example. I know here at Fort Dodge, at the high school, they have a robotics club now. That would be not only interesting, but it would be beneficial to students. That one of the main selling points for our program is that we have 10, well now 11 robots, industrial grade robots in our facility, and the students get to touch those robots every day. So where they might go to another program and talk about operating robots or run simulation software, they get to run the simulation software and the robots in our program. The job outlook in this career is that they need more people, period. There is constantly growing and they need more people. And every year we have about 35 to 40 companies come to us asking us for students, asking us for graduates, and we can only help so many of them. So if you were graduated from the Industrial Robotics and Automation program, you could seek a job at a company such as Barilla, making pasta. You could go to Georgia Pacific. You could go to Elanco here in town. Any industrial setting that deals with automated mass production. Wages are a big question for me every year. And every year the wages seem to be increasing. When I first started the program, it was about $26 to $27 per hour coming right out of school. Yesterday, 2 days ago, we had an employer talk to some of the students, and they said that they would be starting them out at $30 per hour.
I'm a second year student. You get into this on your second year, start learning this stuff your second year. Your first year is learning a lot about pipe bending. You learn residential, industrial, and code. Learn a lot of code, but it's very useful stuff. Or the hands-on is huge. You learn so much with the hands-on.
So basically what we do here at Iowa Central is when you start the semester, this is all there. And we teach you what all these components are. We teach you what PLC is. We teach you what the fuses are for, what the disconnects for, the power supply, the terminal strip. We let you wire all this up to the PLC. Once you wire it all up, you're left with a bunch of push buttons and pilot lights, selector switches, key switches, so that you can sit down on the computer, write a program in the spring. We get you into here and give you some DC components and let you wire it up to this PLC. And then we sit down with a little different version of the software. And you start out by programming this stuff the same way that you program this stuff. And then once you get comfortable with all of that, then we get into the graphic screens, the HMI screen. We also teach you how to put your buttons onto a screen, a touch screen, so that I can push a spot on a screen and have the screen do different things. So I can actually activate my machine by simply pushing those buttons that I program into that screen. If I want that button to move, I simply have to go into the software, drag that button over and move it. If I want it to change colors, I want it to change the name on it, all of those different types of things, I just get into the software and make those changes.
This is a universal collaborative robot. This has a servo motor in the gripper, so it's able to pick up any object set force. So it can pick up this egg without cracking it.
I would say come to Iowa Central. I would say come out here and have some fun. Play with this industrial equipment because this equipment is exactly what you're going to see in the field.
All righty, so I apologize. I know that might have been lagging for some people, so I will make sure to drop the link in the chat. So if you want to go back and watch his video at any point in time, then you have it. So go ahead, Thad.
All right, so the video was a little bit spotty, but you get the general overview of things. The robots and things run much smoother than what they did on the screen. My background, as I said, I was in the field for 15 years. I dealt with all of this equipment. So when they asked me to start this program, I said, you're gonna have to buy me the equipment to work with, because I'm a firm believer in the hands-on aspect of things. I know most of the people who come to an industrial type setting in community college, they are looking for a hands-on situation, because when they get out of here, they're going to be hands-on. So why not work with the equipment they're going to be working with, right? So I take them into the lab every day and sit down and work with robots on a regular basis, so that when they get out of here, they're not afraid of robots. They're not afraid to maneuver the robot. They're not afraid to write a program for a robot. They're not afraid of what's going to happen. They know what's going to happen. They're pretty well versed in everything that we do. Megan, am I able to share my screen?
Yep, you should be able to.
See where I can share it here. I lost the share. Nope, I'm not seeing it. Let's do this. There it is. Okay, I'm going to show you some of the software that we use. Obviously, we have 10 robots here, 10 industrial grade robots, and then we recently purchased a collaborative robot, which means the robot that picks up the egg, because it is servo driven and the end of arm effector is servo driven, it can sense the amount of force that it puts on something. So it is able to pick up an egg without breaking the egg. I also just got approval. We are going to buy a used mobile robot here in the next couple of weeks. The mobile robots are basically able to guide themselves around a room, go pick up something, retrieve a box of parts, for example, pick it up, take it over to somebody else, take it to a line worker, for example. So the line worker can use the parts out of that box, and then the robot, when the box is empty, the robot goes and retrieves another box. Those robots have to be very safe, because we obviously don't want robots running over people in an industrial setting. So they have several sensors on them to measure 360 degrees. They see everything around them, so to speak, so that when someone would walk in front of that mobile robot, it would stop and pause for a given period of time before giving someone time to walk past it before it starts running again. So hopefully here you can see my screen. This is the software that we are currently using for our industrial robots in our lab. Now, what we did with this, let's see if I can minimize this. What we did with this was take our lab, what we have in our lab, we measured out the table, we measured out everything else. Is that not showing up? I don't know why that's not showing up. All you can see is my flex pendant, right? Let's do a new share. Let's try this. Oh, that's not working very well. I'm going to stop sharing for a second.
Okay.
I will go over here and start sharing again. Let's try this again. There we go. So what we have here is our setting in our lab. We took all of the measurements from our table, from our robots, from our conveyors, everything. We took measurements on that, put it into an AutoCAD file. For any of you, I know Ed Berkey out at the high school offers AutoCAD. For any of you who are interested, I would highly recommend taking an AutoCAD course, because you probably will get into that at some point in your career. Typically, what you do outside of here is when you graduate from college, you're going to start on lower level of things, you're going to be running wire, like Justin said in the video, going to be running wire and conduit. But as you progress and you move up the proverbial ladder, you will be asked to do more tasks. And one of those tasks will be to design equipment. You may even step into some type of engineering role. Now, the engineering, when I say engineering, it's a little bit different than when Neil says engineering, because my type of engineering, you're going to sit down and design some things and set up a project and make it happen. You're just basically coordinating all of the things, putting all the pieces together, and then giving the overall plan to some other guys and letting them do the task. Because we have a background in AutoCAD, we are able to measure the table, we're able to measure the robot, we're able to measure the conveyor and put it in that AutoCAD file so that I can actually put this in my software and give this to the students, so that the students are able to go home and write a program. They're able to sit down on their computers without a robot and write a program. So as you see here, I've got a robot, and see if I can get my Teach Pendant back. So you guys won't be able to see that, but you can see this. Yes. So if I go to a joint move, for example, I can highlight any part of the robot and I can move the joint on that robot. So if I highlight right here, for example, I can move that robot. I should be able to move that robot. It's not moving. All right. Take my word for it. It will move. I am able to grab this with a cursor and drag it. There it goes. I'm able to drag it around so that it actually manipulates the robot. I can also write a program onto my Flex Pendant. Let's do a new share here. And see that? Nope. Anyway, I have a Teach Pendant here that we normally use in the lab. You saw that in the video where they grab the Teach Pendant and they use the Teach Pendant to program the robot. On the Teach Pendant, there's a bunch of uninterpretable language at this stage of the game. When they first walk in here, they have no idea what all of this language means, what all this code means. Neil showed an example of some programming code. It looks similar to some of the things that Neil uses to program. You actually program a move instruction in there and have the robot actually move to a specific point and do specific things. And then you can actually hit your play button and actually make that robot execute that program. Now, right now, I don't have a program written for my robot, and my software is being very temperamental today, so it probably isn't going to work very well anyway. But you get the general idea, hopefully, of what we try to do here. At one point, like the fourth semester, I will take students. I will say one of their assignments is to design a mass production situation where they have to write a program for their robot to go down and pick up a part and put it on their conveyor. Or they have to go down and pick up a part, hold it up to their vision system. The vision system, the camera actually examines the part based on the image that they design. And if the part falls within the limitations of their image that they set up, then they can put that on their conveyor and send it on down the line. It's a good part. It's a pass is what we call it. If it holds it up to the camera and the camera says that doesn't fall within the limitations of the image that you created, that's a fail. So it won't send it down the line. It will put it in a bad box, and then we'll rework it. And I will tell students, go home and write a program for the first stage of that process. You go home and write a program for the second stage of the process. You go home and write a third stage of the process. So essentially, I could dump a bucket of Legos on the table, and I can say, Megan's going to write a program to assemble the green and red Legos using a blue Lego. Hold it up to the camera. Make sure the Legos are assembled. Make sure they're square. Make sure they're the right size. Make sure the color pattern is correct. And if it is, put it on the conveyor. Now, Shelly's going to go home and write a program for the next robot to grab the part off of Megan's conveyor, set it on her table, and she's going to add a green Lego or a purple Lego. She's going to hold it up to the camera, see if the part is falling within the specifications of the image. If it does, she's going to pass it on down the line. and pass it to Mackenzie. And when the students come in to the lab, we are able to load those programs onto the robots, tweak the positions just a little bit, and we're able to simulate a mass production situation. I think that I have bored you enough so far, so I'm going to open this up. Since the software isn't working very well, I will open this up to any questions that anybody might have about the program or about what we do.
Okay, Thad, I do have a question. It's the same one I asked Neil, but how long, and maybe you mentioned this, but how long does it take the students to learn to work with the robots or even any of the equipment that you have or the software?
As far as the robots themselves, they are working with the robots in probably the second week. I mean, their first semester, they're coming right out of high school. Their first semester, they walk in here, and their second week that they are here, they have hands on the robots. Now, they don't understand necessarily what all of the coding means, but we aren't worried about writing code and writing programs right away. We have to do a few things. It's called tool center point identification and work object identification. They have to learn those processes first. And once they get those processes down pat, after about 4 weeks, they start writing code. We start learning what each individual move instruction means. We learn what the velocity, the zone, the work object, and the tool elements of each of those move instructions means, and why they are important, and how we change them, and how they can be important in an industrial setting, in a mass production situation.
And what about Job Outlook? I know we spoke about this the other day when we had met and you explained it really well, but who are the employers that would hire a student? And then also, what about, is it a high demand right now? So are students in the program around anywhere, whether it's Iowa Central or anywhere, are there employers knocking on their doors?
We have been contacted this year and last year by employers that have never contacted us before. I spoke with Wells 2 days ago or 3 days ago. I spoke with Interstates. Interstates has developed a partnership with us 5 years ago, but they were mainly looking for the electrical technologies students, for guys who could bend conduit and run wire. This year, they sent their automation department to us, and they're looking for automation professionals now. Companies are reaching out farther to more schools because there is such a high demand of automation technicians. For every 3 people, for every 3 technicians, or for every 3 technicians that are retiring right now, only 1 technician is entering the field. So they have to find a way to compensate for all of that. And nobody has found the answer yet. So that's why I highly recommend the field. The students have 100% higher rate coming out of here. They will go to places like Burrell Pasta down in Ames, Tones Spices down in Des Moines, Accumold down in Des Moines, Elanco, or what they call it, Fort Dodge Labs. That's what people commonly know it as here in town. Just any place that is mass producing any type of product is going to be begging for automation technicians. I have even talked to companies like ABB and some other third-party companies that do nothing but install robots and write programs for companies like Barilla and Elanco, places like that. So they typically go around writing programs and installing robots as a career.
Awesome, thank you. And then what about skills? I know we get a lot of questions from the high schools about what are good skills. And then also the second part of that is, if a student is interested in this career, what should they know, or should they come prepared, or are you guys able to train them and teach them the skills that they are going to need to know in the workforce?
Okay, the main skills that I focus on on the automation side of things, I make sure the most important part they are able to troubleshoot. Because I don't care who you are or what you do, when you install a new system, something is not going to work properly. And that applies to all works of life. I mean, that's Murphy's Law. So if they are able to troubleshoot systems coming out of here, they are worth their weight in gold. If they are able to walk out of here knowing how to program things, how to work with AutoCAD, how to wire things up, wire systems in, how to wire PLC systems in a neat and workmanlike manner, they are going to be invaluable to a company, to any automation company. So as high school students, I would highly recommend, I know Ed Berkey has the AutoCAD classes out there. I know Ed Berkey has some machining classes out at the high school. I know that there's the robotics club here in town. I would recommend doing any of those things or all of those things. But if you don't, I have set up the program so that we are able to bring someone in. I would be able to bring Megan in to the program and start teaching Megan how to run a robot within the first 2 weeks. Now, I mean, not to bash on you, Megan. You already told me that you don't know anything about robotics.
Yeah, I know nothing, so that'd be interesting.
I would be able to bring you in here in 2 weeks. I would be able to teach you how to run, at least manipulate a robot manually. And then after that, we would start talking about tool center points, work objects, and move instructions. And then once you get into your third semester, we'll start talking about programmable logic controllers. In your fourth semester, we start talking about HMIs, the touch screens, programming the buttons on the screens.
That is awesome. That'd be quite a challenge, but wow, that's good to know. Okay, are there any other questions before we start wrapping the STEM Career Day up? And Neil is still on too, so it looks like Thad and Neil, I know would both take questions. So like we said, if you want to use the chat, you absolutely can. Otherwise, you can unmute yourself and ask questions too. Oh, I just got a private chat. It looks like a student is wanting to know if there's any other advice that you would give. So either one of you can take that or both of you can take that.
I could start with that and then send it over to Neil. My first suggestion would be attendance. If you come to a school such as this, whether you're in my program or Neil's, you need to be here. I can teach you things even when you have no background in it. I can teach you things, but you have to be here to learn it. And I carry that over because I'm a firm believer in that, because I worked in industry. You have to show up for work every day and you have to show up on time. Employers, you're not valuable to an employer if you're not there. So get to your classes, get there on time, take notes while you are in your classes, and learn the material that is presented. Learn it as much as possible. I can't tell you how many students have come to me after graduating and said, thanks for what you did. I wish I had paid more attention in your classes. I wish I had taken better notes. And I'm sure Neil can verify. There are so many students who get out there and wish they had paid more attention. So those are my stress points. Go ahead, Neil.
I think you took quite a few of mine. Thank you. But I think probably what I would add on to that is that you must come to terms with the fact that learning never stops. And the bulk of my learning, I mean, I did a lot of learning in college. College was really good for me. It was a real shift in mindset for me. I needed those years in college to take care of some of the immaturity I had in high school. I learned a lot in college, not only fundamentals about how to be successful in my career, but how to work with other people. But the biggest discovery for me was when I got out into the workplace, was that learning never stops. It never stops. And the sooner you make your peace with that, and the sooner you learn to love that, the more successful you're going to be in what you do.
Definitely, I agree. I always tell my students that the day that you stop learning something new is the day that you are either dead or you are no longer successful in your trade. And it may not be something about engineering. It may not be about robotics. It may be something about gears or hydraulic systems or any number of things, but you're learning something new every single day.
Awesome advice, both of you. Appreciate it. Okay, well, if you guys don't have anything else, we're going to go ahead and wrap up so we can end up on time. Kenzie is going to share right now contact information of the instructors. So like we mentioned before, if you have questions, do not hesitate to reach out. These, starting with Neil, Jenny, Julie, and Thad, you can see all their contact information right there. Also, your instructors and counselors, etc., do have Mackenzie Holly and my email, so you can also reach out to us if you have any questions. If you're interested in a job shadow, please do let us know, whether it's with an instructor or a business. We can also help you get connected. And if you do take a job shadow with us and you complete one, you get a $250 scholarship to use at Iowa Central if you choose to go here. And if not, that is completely fine. You can still do a job shadow with us. So if no one has any other questions, it looks like there's nothing in the chat. We're going to go ahead and end. So thanks again to all the instructors. Thank you, Neil. Thank you, Thad, so much for taking the time to talk with us. And thank you for all the schools for getting on. We really appreciate it. So take care, everyone. Thank you.